welcome to Universe's Lake. My name is Astronomer George. I and my friend Astronomer Richard will explain you about universe. In this video, I, Astronomer George, will explain you. Today we will discuss about, is there any star where life can exist, and if so, is there water on it? So let's get started. What came before the Big Bang? The truth is, we don't know for sure. Time and space as we understand them began with the Big Bang, 13.8 billion years ago. Before that, physics breaks down. Some theories suggest a previous universe collapsed, others say it was pure quantum chaos. But one thing's clear, everything we know started with that explosion.
In the first fraction of a second, the universe expanded faster than the speed of light. It was unimaginably hot and dense. No atoms, no light, just raw energy. As the universe cooled, energy transformed into particles, quarks and electrons. Quarks joined to form protons and neutrons. About 3 minutes later, those combined into the first atomic nuclei, mostly hydrogen and helium. For the next 380,000 years, the universe was a hot fog. Then atoms finally formed as electrons settled into orbit around nuclei. The fog cleared, light traveled freely. The universe had become transparent. Gravity began pulling atoms together. Dense clouds of hydrogen collapsed. Pressure and heat rose until, boom, the first stars ignited. In their cores, fusion began, atoms merging to form heavier elements. Those first stars lived fast and died young, scattering elements across space. From their ashes came new stars, planets, and eventually us. All made from star stuff, all from a moment of cosmic fire. Before the Big Bang may be a mystery, but what came after? That's the story written in the stars.
Born from stardust, atoms became cells, cells became creatures, creatures learned to think, and here we are, trying to understand the stars that made us, and around stars like our sun, called yellow dwarfs, or smaller, cooler red dwarfs, planets can orbit in the habitable zone, not too hot, not too cold. If a planet lies in that zone, it could have water, and many exoplanets may have water, some even oceans. Water is common in the universe, and where there's water, there could be life, like us. Can there be a star where life can exit? And if so, can there be water on it? In brief, located 370 light-years away, PDS 70 is a young K-tongue star surrounded by a protoplanetary disk, a region where planets are forming. JWST detected water vapor in the inner part of this disk, the zone where rocky, Earth-like planets could emerge. This marks the first time water has been found so close to a star in such a disk, suggesting that nascent planets here might incorporate water from the very beginning. HD 181,327, situated 156 light-years away in the constellation Telescopium, is a young sun-like star encircled by a debris disk rich in icy bodies. JWST's observations revealed the presence of frozen water, or ice, within this disk. This finding supports the idea that water ice, delivered by comets and asteroids, could play a crucial role in supplying water to forming planets. GJ 4886 is a red dwarf star located 26 light-years from Earth. JWST detected signs of water vapor in this system. However, scientists are still determining whether this vapor originates from the rocky planet GJ 486b's atmosphere or from the star itself, possibly from cooler regions known as star spots. Regardless, this observation showcases JWST's sensitivity in detecting water in various stellar environments. These discoveries highlight that water, a key ingredient for life, is not exclusive to our solar system. By detecting water in the disks around young stars, JWST provides valuable insights into how planetary systems form and evolve. As we continue to explore the cosmos, each finding brings us closer to understanding the potential for life beyond Earth. Yes, there can be life on some stars like we discussed, and especially HD 181, 327, but it's not proven, and water can't be on blue stars, and especially Wolf-Rayet stars, but you will now say that HD 181, 27 is hotter and brighter than our sun, But why there is no water on Sun? Because water can't be on G-type star, and HD 18127 327 is F-type star. And main reason, it's just so young, only 23 million years old, and Sun is 4.5 billion. It's just born, and it hasn't yet burned helium and hydrogen. And truth is, Sun also had water on it when it was young, about 10 to 30 million years, but later when it started to burn helium and hydrogen, so water ended. Same will happen to HD 181. So, so 327 later, but now it always so young, and if life exists, so it will soon end. When HD 1687 will start to burn helium and hydrogen. And now let's see a quick comparison property. Sun, HD 1687, spectral type G2V, yellow dwarf F6V, white yellow. Surface temp K, perfect H till T 507.8 till 2435 K. Core temp K, that's from tilde 15 million K. Core temp K, speed temp 2.2 A till 2.3 million years. But now you will say HT 181,000. 3217 is hotter than Sun, but why is there water around HD 181,327 1? It's found in the star's debris disk. HD 181,327 is surrounded by a debris disk, a ring of cold dust, ice, and rock orbiting the star. This is similar to our own Kuiper belt, which contains comets and icy objects beyond Neptune. Okay, JWST detected frozen water, ice grains in this disk. The ice is located far from the hot star in the outer, colder regions where temperatures are low enough for water to freeze. 2. Water ice forms in cold space. Water molecules easily form in cold interstellar clouds even before stars are born. When stars like HD 181,327 form, they inherit this icy material. In the outer disk, water remains frozen as tiny ice particles or on dust grains. These icy bodies can later become comets or water-rich asteroids. 3. Building blocks for habitable planets. This icy material is essential for planet formation. If planets form in or near this disk, icy comets and asteroids might deliver water to them, just like they did for Earth. In short, water is around HD 1,327 not because of the star itself, but because cold, icy material left over from its formation still orbits it. This water is frozen, protected from the star's heat by its distance in the outer disk.
Now you will start to wonder that how astronomer George changed. So reason is that astronomer George had important work. So he left, but then astronomer Richard you already know. So he came, and later on he had also important work, and he also left, then astronomer plus physician Johnson came, and later he had also a important work. So he also left. Then finally, I astronomer plus physician plus writer plus software developer plus chemist plus mathematician, William came. And sorry for not discussing this, and don't forget to like, subscribe and share, and also click bell icon for new update. Thank you for watching. Meet you in next video.